Okay, we're going to solve this rational equation. 3x plus 5 times x plus 8 over x minus 2 is less than or equal to 0. Solution. Step 1. We are going to factor each of the top and the bottom. Well, first step 1 is get everything over to the left side. That's already done. We have everything on the left, everything on the right is just 0. Step 2, factor the non-zero side. That's already done also. Step 3, we're going to set each of our factors, top and bottom, equal to 0 and solve. So we have 3x plus 5 equals 0. We have x plus 8 equals 0. We have x minus 2 equals 0. Solve, we get 3x equals negative 5. In other words, x equals negative 5 over 3. Here we have x equals negative 8. Here we have x equals 2. So those are all real numbers. Step 4 is what we're going to use to partition a number line, leave some space, and draw a number line out here. We're going to use all these three numbers to bust up a number line. Okay, what's smaller, negative 8 or negative 5/3? Well, negative 5/3 is a little more than 1. It's actually negative 1 and 2/3. So negative 8 is definitely the smaller. Then comes negative 5/3. And finally, we get the number 2. Now, I didn't evenly space them. I just stuck them anywhere, just as long as they're in the right relative position to one another. And we're taking this x-axis, these are x values, we're partitioning it using these roots, these zeros, or the roots of the rational expression on the left. And then now we're going to do the sign graph deal, and that involves checking the sign, positive or negative, of the first factor times the second factor over the denominator factor. So this is step 5 and 6. What we do in step 5 and 6 is we go ahead and figure out the positive or negativeness of each of the factors in each of these regions. There are 4 regions on this number line that have been partitioned. And then we're going to find the actual sign of the entire rational expression. So choose a value for x to the left of negative 8. Let's choose something like negative 100. X equals negative 100. When x is equal to negative 100, 3 times negative 100 plus 5 is going to be a negative number, times negative 100 plus 8, that'll be a negative number, and then negative 100 minus 2 will also be a negative number. So on the top, we have a negative times a negative, which is a positive, over a negative gives me a total negative value for this fraction. Now let's choose a value between negative 5/3 and negative 8. Let's say negative 7. That lives in there. Negative 7. 3 times negative 7 is negative 21 plus 5. That's negative. Times negative 7 plus 8. That's positive. Divided by negative 7 minus 2. That's negative. So on the top we have a negative because negative times positive is negative. Negative divided by a negative gives us a total value of a positive for the fraction in this region. Now between negative 5/3 and 2, a nice number to choose for x would be 0. That lives in between there. 3 times 0 is 0. Plus 5 is positive 5, so that's a positive. Times 0 plus 8 is positive 8, that's a positive. Divided by 0 minus 2, that's a negative. So we have a positive on the top over a negative. So together, the entire fraction is negative. And finally, for values of x to the right of 2, let's choose x equals, say, 100. 3 times 100 is 300 plus 5 is positive. Times 100 plus 8 is positive. Divided by 100 minus 2, that's positive. Positive over positive gives us a positive result. So at the bottom what you see is the result for the value of the entire rational expression that's on the left in the question in each of these 3 regions of x. So on step 7, we're supposed to refer back to step number 2, which was actually the question 3x plus 5 times x plus 8 over x minus 2. less than or equal to 0. And what I want you to note is to be less than or equal to 0 means to be negative. Negative. So step 7 is saying to shade the regions for which the expression in step 2 is true. In other words, where the rational expression, the fraction, is negative. Well, that's going to occur in this region and in this region. That's where the entire fraction is negative. So let's shade this region here with an arrow. And let's shade this region. Now we don't know about the endpoints of these shaded regions, so let's go to step 8. For step 8, we're going to check the endpoints. We note that we have a less than or equal to inequality in the original question. So that implies include endpoints except values that make bottom 0. Okay, so let's think about this. We've got the endpoint negative 8 on the graph. Does negative 8 make the bottom x minus 2 equal 0? Well, let's see, negative 8 minus 2 is negative 10. No, it doesn't, so we can include it. Let's put a big boxy bracket on it. How about negative 5/3? Negative 5/3 minus 2, that's not 0, so we can include that with a boxy bracket. And how about 2? 2 minus 2? Oh yeah, that one does make the bottom 0, so you better not include it. Put a round bracket. And then finally, step 9, right answer. And we'll do it in interval notation. And that will be the values of x that make the inequality true that was given to us are x values from negative infinity all the way to negative 8, round, whoops, it's supposed to be a negative 8. Okay, so we always put an open bracket on negative infinity, and we had a boxy bracket there on negative 8. Union that interval together with everything from negative 5/3 with a boxy bracket up to 2 with a round bracket. And that is our final answer. Those are the values of x that make the inequality true.